All right, exponential equations. What makes it an exponential equation is pretty easy to see. Now, the first couple of these that I work, you can look at them and tell the answer. All right? But I want to show you the steps that you would use so that when we get to the ones that you can't just look at them, you would know the process to get the solution. Fair enough? So on the first few, you're going to know the answer. Well, let's do this one. 3 to the x equals 81. And I know everybody here knows the answer is 4. That's fine. You know the answer is 4, but I want to show you how the procedure you would do if you couldn't see that it was 4. Okay? What you do is you make the bases the same. You make the bases equal. Make bases equal. Now, someone says, no, I'm going to do, no, we're not going to pull out a calculator and spend 5 minutes on a problem that doesn't take that long. All right? You make the bases the same. So you do 3 to the x, and if you recognize 81 is 3 to the 4th. Notice, if the bases are equal, the exponents have to be x equals 4. So the key is make the bases equal. That's the whole key to working these. And it's fast. If you look at the ACT test, near the end of the ACT test, there's always one of these. And if you do it on the calculator, it's going to take you 2 or 3 minutes. If you do it by making the bases the same, it's just instant answer. All right, now, this one you probably just can't look at. And that's what I'm getting at. But we're going to make the bases the same. Now, someone says, well, I can't make 16 to 8 raised to some power. Yeah, it'd be nasty. It wouldn't be something you want to do. All right? So what you would want to do is think of making both of these 2. Making this 2 to the 3rd. And making this one 2 to the 4th. That way you can make both bases 2. 2 cubed, 2 to the 4th. Now, when you do this, when you raise a power by a power, you multiply. You know that. You know, I've all had good algebra 2 backgrounds. You know that. Just please use the distributive property. Now, if you were to go from here down to here, it wouldn't bother me a bit, folks. I'm just putting that step in there to show that little bit of information. Then you simply set 3x plus 3 equals 4. You finish it off. 3x equals 1. X equals 1/3. Make the bases the same. Make the bases the same. You need to get rid of the 1/2. You need to make the 1/2 a 2. You need to take its reciprocal, right? But okay, it's going to need to take its reciprocal. What exponent means reciprocal? -1, right? Back row, sleep, -1 means reciprocal. So y'all all right if I just write 2 to the negative x equals 2 to the 5th? For 32, 2 to the 5th. And then x equals -5. So anytime you need a reciprocal, use your -1 exponent. Some I've been doing in the earlier classes. So we'll do it here. Just in case you need a little help, 2 to the 0 equals 1. 2 to the 1st is 2. 2 to the 2nd is 4. 2 to the 3rd is 8. Y'all know all this, but it just helps to make a list. And we're going to use this list when we talk about something we're not supposed to do yet. Okay, so there you go. And 2 to the 0 is equal to 1. I put that one up there just to reinforce when you raise it to the 0 power, you get 1. 3 list. Well, 3 to the 0 is equal to 1. 3 to the first is 3. 3 to the second, 9. 3 to the third, 27. 3 to the fourth, 81. And go ahead and do 3 to the fifth, which is 243. And since I've taught this 4 times today, I'm already forgetting to tell you things. This one right here is on the ACT test. Every year there's somewhere that if you know 2 to the fifth is 32, you just save yourself a lot of time on the ACT. They just like that one on standardized tests. Okay? And if you do your 5s, 5 to the 0 is 1, 5 to the first is 5, 5 squared, 25, 5 to the fourth, 5 to the third, 125, and 5 to the fourth is 625, and I just know that the guy, Sisson, book uses 625 a lot. That's one he likes, so I'm going to put it up there. All right. Make the bases the same. So far, so good. Any question about anything on the board before it disappears? Okay. Make the bases the same. Now, five halves raised to the x equals 4 over 25 raised to x minus 1. Okay. One of these you need to take the reciprocal of. And it doesn't matter which one you take the reciprocal of, it'll work either way. But I always like to take the reciprocal of the one that's improper. Okay? You can take the reciprocal here, or you can take the reciprocal here. It's still going to work. But notice, one of them's a proper fraction, and one of them's improper. So one of them you have to take the reciprocal of. Take the reciprocal of this one. 2/5 raised to the negative x. And you probably have already realized, if I make this, what? 2/5 squared. Is everyone okay that that is 2/5 squared? Yeah, 2/5 squared. So 2/5. Do y'all mind if I go ahead and make that 2? No, I'm not going to skip a step. Because I want you to see I got to multiply what? The powers, right? I know what y'all have done. Y'all have just written 2x minus 2, right? That's what most of y'all wrote, and you're happy with that. And that's probably what I should have written. You know, I'm also having to teach the little children that are at home, and they might need to see that. 2x minus 2. Once you get here, your bases are equal, set your exponents equal to each other. And x equals 2/3. That's about as complicated as the fractions can get, is where one's proper and one's improper. Take a look at it. See if you really look at this. Don't. Now, I'm probably supposed to give you a problem, let you work to see if you can do it, but we're not there yet. All right, 0.5 raised to the x is equal to 0.25. All right, if you ask me to cube 0.5, that's probably not going to be really easy for me to do. Or if you ask me to square 0.25, that's probably not something I want to try to do. In my brain, I'm already converting them to fractions. We do not work decimals like this. Convert them to fractions. Change the decimals to fractions. Change the decimals to fractions. 1/2 raised to the x equals 1/4. All right? Now, 1/2 raised to the x is equal to 1/4 would be what? 1/2 what? Squared. So 1/4 is the same thing as 1/2 squared, and you get x equals 2. It'll be easy to do these if you will change the decimals to fractions. Don't ever try to work them as decimals. Okay? Somebody wrote that in their notes. Do not try to work decimals. Put a little note there how to do it. Right? You need to take a reciprocal of the fraction. Use what? -1. Okay. E to the x minus 1 equals e to the third times e to the x plus 2. All right. Even if you don't know what e is, you know that both bases need to be what? E, right? And you can make the base on the right be e by multiplying these two together. And what do you do to the exponents when you multiply them? You do what to the exponents? You add them. So you'll get e to the 3 plus that. I'm actually going to write out the step. You're going to add those exponents. And then x minus 1 equals x plus 5. And then you get 0 equals 6. You get a false statement. The x is added out, and you get a false statement. That means it's empty set. There is no solution, which I didn't mean to make up, but that's what it means. All your variables go away. All your variables add out, and you get a false statement. It's empty set. Guess what happens if all your variables go away and you get a true statement? That means there's multiple solutions. A bunch of numbers work, an infinite number of solutions. All rational numbers. So I didn't mean for this to happen, but I got to review a little notation with you. All right. Does anybody know who E is named after? E is a special number, just like pi. It's so special we gave a number a name. E is named after the famous mathematician, famous scientist, mathematician. Einstein. Miss, who guessed that? Miss?
Arden. Brainus.
Miss Brainus. Okay, Miss Brainus, I would laugh at your brother if he gave me that it was Einstein, because that's wrong. But for you, I'm going to tell you the truth. Einstein is a real good guess. Come on, Einstein, famous mathematician, famous scientist. Einstein's a good guess. You don't get bonus points for Einstein, but you don't get laughed at either. Anyone else? Ma'am? Oh, okay, yeah, good. Let's say it right, though. It's spelled E-U-L-E-R. It's pronounced for us Americans that have trouble, especially Southern Americans like myself, more like Euler. 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 But it's spelled like that. That's who it's named after. That's not the famous mathematician I would give bonus points for. I don't give bonus points for getting that right. Okay? But that's who it is. And what happens is when you look in biology and you look at growth rates, you look at money, and you look at continuous interest rates like the banks use, okay? Or if you look at radioactive decay, y'all heard of this stuff called half-life? How long it takes to cut the amount in half? How long it takes to cut the amount in half? If you look at all those formulas, there's this number 2.71 that is in all those formulas. And that's about E. E is like pi. Pi is not really just 3.14, right? Well, E is not really just 2.71. It's a number like pi that's irrational. It goes on and on. But all those formulas use E. And so you'll see it in your biology classes, your chemistry classes, all kinds of classes are going to have E in the formula. And it works just like having a 2. Matter of fact, people always ask, well, how did you get so close to the answer? Well, I just estimated with 3 or estimated with 2, right? You estimate with 2, you get an answer that's too small. You estimate with 3, you get an answer that's too big. Yeah, it's 2.71. That's not the famous mathematician that gets you bonus points, though. Famous mathematician that gets you bonus points. Kind, caring mathematician. Not even close to the right answer as far as great mathematician. Just a kind, caring man that wants you to learn math.
You.
Evans, that's right. You may get you laughed at, but it'll get you bonus points. Yeah, I'll laugh at you for Evans. I mean, it's way wrong, but it's worth bonus points. All right. There was a Dr. Brainus at Tech, just joking, I just used Brainus because it begins with a B. But there's the beta something theorem in history. And in his class, he would always go, who is the beta gamma theorem named after? Beta gamma theory is named after a famous person. Who is it? Dr. Brainus. See? Because, you know, he gets a laugh out of it even though it's wrong. I hope you're smiling under that mask. All right, now, the best way to work these and the best way to learn how to do this is to work a lot of them. So, what you're going to do is notice I got his name right there. There's Orr right there. Leonard Orr. And we're going to talk about him going up the Transcendental Mountain pretty soon. Transcendental Mountain. Okay, solving exponentials. Exponential equations. I want you to work all of them. 22 through 47. There is a key down below that when you look at it. Or you can go up front and take a picture in the book and take a picture on the key if you need to. All right? And you've got